Okay, good morning, everyone. How did your homework go? Do you have any questions before we start? Okay. All right, today the idea is basically to review for the exam. So it will be very helpful for those of you who look at the exam to put your questions on chat. So I will go through them. Okay, so please, if you have questions, just start putting them on chat. I will start, I graded your quiz yesterday. I will start by pointing out the mistake you had on your quiz while you guys put your question on chat. The problem that you had trouble with on quiz 6 were number 1, part B. Yeah. Okay, so we had the function h of x equals, so this is a review for the quiz you had. H of x equal cosine cube x. Okay, and the question is to find the derivative. What a lot of you didn't pay attention to, is to rewrite this as cosine x to the power 3. And by rewriting it this way, we can immediately see what is inside and the outside. So without writing it this way, you don't know what's your inside and outside. Once you write it this way, your outside would be f of u equal u to the power 3. And your inside would be u or g of x equal the cosine of x. Okay? So unless you write it this way, you actually will have difficulties answering this question. So with this in mind, h prime become the derivative of the outside, but you evaluate it at the inside, you times it by the derivative of the inside. Okay. Now, here, the derivative of the outside is 3u squared. So this would become derivative, but instead of u, you put cosine. So 3 cosine x squared times the derivative of the cosine, which is minus sine. Okay. So I'm trying to see if I can get a better picture. Yeah. So some of you messed up this problem. Now, another question that gave a lot of you difficulties is the last problem. And unless you write things clearly this way, you're going to mess up the last questions like the last problem. So I will go through the last problem very carefully. I had the following. I gave you a function f. I gave you some information. So I told you that f at 2 takes the value 3, the derivative minus 4, f at 4 is 3, and finally the derivative at 4 is 5. Okay, I gave you a bunch of information. And then I asked you to do the following. First, f of x equal, I took a function which is x squared times f of x. So very much stuff like even repeated yesterday. And the question is, I want you to evaluate the derivative at 2. Okay. Now, the first part you do is, the first thing you do is find the derivative for any x. You don't plug in 2 yet. Now, this is a product of 2 functions. Okay, so to find this derivative, you have to apply the product rule. The derivative of x squared is 2x times f of x plus x squared times f prime of x. So that's a product rule. After you do that, okay, you want f prime at 2. So remember, f prime at 2, you should get actually a number in here. Then you plug in 2 for x across the board. So you will have 2 times 2 times f of 2 plus 2 squared f prime of 2. And now we have it. It's 4. F of 2, I gave it to you. It's a 3 plus 4 And f prime of 2, I gave it to you, which is -4, and then you get a -4. Okay, so whenever you have to find derivative at a specific point, first you find it for any x. After you do that, then you plug in 2 for x. And you have to plug it across the board. So you don't plug it in one part and you forget to plug it in another part. All right, so we will do the other two now that I have your questions here. What was it? Okay, f of x. It was 1 over f, and we need to find the derivative at 2. So the same type of questions, and this is the given. Okay, and let's see here. So to find f prime, we have to use the quotient rule. So that's 1 over this, we use the quotient rule. So what is f prime? And I will point out the mistake some of you did. The derivative of 1 times f of x. The derivative of 1, it is 0. A lot of you, I don't know, they forgot about that. Minus 1 times f prime over f of x squared. But this is 0. That's the derivative of 1. So this will become 0 minus f prime over f of x squared. Now I evaluated. Once I found it for any value, I evaluated at 2. So it's going to give me minus f prime at 2 over f of 2 squared. And now I pick up the values from here. And let's see what we got. F prime at 2 is -4. And the minus f of 2 was a 3. F of 2 squared, it's a 9. F over 9. Okay. Now, some students, and they did the following way, but I have to point out their mistake as well. Some students, and rightfully so, they took f of x and they rewrote it like that. Okay, which is absolutely fine, which is absolutely correct, which is nice. But now what will become the derivative? Again, here we have to be careful. You're going to have an inside function. So f of x here, the inside will be f of x. And the outside, it's u to the -1. So the derivative is going to be the derivative of the outside, which is -1, u, and then I will substitute u by it, then this is my u, to the -1 times the derivative of the inside. And that's the piece a lot of you missed. So, which will give me minus f of x to the -2 times f prime. So if you write it like this, you have to remember that this becomes your inside function. And so which is nothing more than minus f prime of x over, because I have -2 here, f of x squared, which is exactly what we got. So if you rewrite it this way, which is very good, but then you have to be careful that you need the inside. Now the last one, which was actually hard for a lot of you, even those who got A and B correct. It was f of x equal f of x squared. Okay, so before I do that, I would like to put some remarks, what I saw, and then I will do the problem. So I saw the following. I saw this. Some student who wrote, this is equal to that. I don't know, they didn't know what to do with the 2 basically. So they wrote it like this. Okay, now is this correct? Is this correct? No, absolutely no. Absolutely no. This is not correct. This is not correct. I mean, take a function. So let's take example. Okay, suppose I take, for example, f of x to be, what's the easy one? Sine x. Okay, so in this case, f of x squared is the sine of x squared. So what you are squaring is the x. However, f of x squared, what you're squaring is the sine of x. So they're very different. And here is the x which is squared. When you write it this way, it's the whole function that you're squaring. So this is not that. It's just you're squaring the inside when I put f of x squared. So now the question is how to find the derivative of that. All right, so again, we have f of x equal. Okay. So f of x equal f of x squared. So the only way to define the derivative, again, we have to see the inside and the outside. That's not a product because that's f of. So this is really a composition. So the inside here is the x squared. So if I'm going to write it inside, outside, and student who did this way had no issue with it. So the inside here and the outside. The outside is f of u. That's the outside. The inside is the x squared function. So that's your outside and that's your inside. So what's going to be our f prime? It's the derivative of the outside, but you evaluate it at the inside. Times, so the chain rule is a product of two derivatives, times the derivative of the inside, the derivative of x squared. So finally, I will have f prime of x squared times the derivative of that, which is 2x. So that's f prime of x for any x. Now I want it for the particular value 2. So f prime f2 equal. So whenever there is x, I have to put 2. So if I put 2 here, I will have 4 times 2x. I have to put 2 in here times 4. Once we've done this, we go pick up the value. I gave you, this is 5 times 4, which is going to give us 20. Okay. So this is how we go about those problems that gave some of you difficulties. And expect those tomorrow. Expect those tomorrow. All right. Now I go back to your questions from the review. So I try to do them in order the best I can. So I will mark them down. So 8, 9, 10, we do that. And then we have 2, 5b. So number 2. Oh, sorry, number 2. Number 5b. Okay, and I have number 8, 9, 10. And 5f, we do that, 5f. And okay, and then 8, 9, 10. 8, 9, and 10. All right, so we start doing those. And if you have time, you guys have any questions, we do them. All right, so I will start with, I'm trying to do them in order. I will start with number 2. And here's number 2. We have a function, f of x. And I define the function this way. It's cx plus 1, so that is a constant, when x is strictly less than 3. Okay, and it's equal to cx squared minus 1 when x is larger or equal to 3. And the question is, for which value or values of c is the function continuous at x equal to 3? So we definitely realize something happened at 3 because the function is changing. My question is, for which c f is continuous? Okay, that's really the question. Okay, anybody had any idea how to do that? Anybody has any idea? Anybody try it?
Do we set both equations equal to each other because they're continuous?
What do you mean both equation?
The cx plus 1 and the cx
So you want
squared.
me to do this? You want me to put cx plus 1 equals cx squared minus 1?
Yes, and then you solve for c.
How can I solve with the x in presence?
Wait, okay, never mind. I think I got it wrong.
Understand?
I was thinking about something different. So.
Yeah, I mean, you're not too bad, but not there. Anybody else? Anybody like to pitch in? So as I remember, if we want it to be continuous at x equal to 3, what do we want? We want the limit. We want the limit. As x become close to 3 from the positive of f of x to be equal to the limit when x become close to 3 from the negative of f of x. So we want the limit to exist, and we want this limit to actually coincide with the actual value of the function. Did you see what I wrote? To be continuous at 3 at this specific point, we want, so in the picture, I cannot even draw a picture here because I have a c in here. So that's why I not even can think graphically, but I want the limit from the left to be equal to the limit from the right to be equal to the value of the function. That's really, sorry, closed here. That's really what I want. All right, so let us set those limit equal. So what is the limit? This one. Okay, from the positive, what is f of x? C is a constant. So C could be 2, could be 3, just treat it as a constant. Now, when x become close to 3 from the positive, this become close to what? If x become close to 3 from the positive, it means x is bigger than 3. It means f of x is cx squared minus 1. From the negative, f of x is cx plus 1. f of 3 is, I put 3 here, I get 9c plus 1. Okay. So I don't put the equation equal to each other. What I put equal to each other is the limit. Limit from the positive, from the right, equal limit from the left. That's what continuity tells me. I want the same limit. I want the limit to exist, and I want it to be equal to the value of the function. And now I evaluate the limit. What's this limit here? I'm listening. What's this limit? Right there. Don't let C scare you. C is a constant. C is 2. C is 4. So don't really let it scare you. What is the limit here?
9c minus 1.
9c, yeah, because don't let C, as I said, don't really let C get in the way. So this is x become close to 9, so it's going to give me 9c minus 1. This should be equal to, when x become close to 3 here, C is a constant. This would become 3c plus 1. So I want those to be equal to each other. Now I don't have to worry about that anymore because it's already there. And now I solve for C. So 9c, that's going to give me 6c equal to 2. C equal 2 over 6. It means C equal 1/3. Okay. So the whole idea here is to say, if I want this to be continuous, I want the limit from both sides to be equal. I want the limits to be equal. I set them equal to each other, and then I proceed and get C equal to 1/3. All right. Any questions about that problem? Okay. I move on to your other questions. All right. B is the following. We have the following function. B is good. X times the square root of x plus x over the 4th root of x plus 5. And here's the question. The question, I want you to find the derivative. And I'll be very precise. I do not want you to use the quotient or the product rule. And I may ask this question tomorrow. So I don't want quotient rule. I don't want the product rule. and I want you to find the derivative. So basically, I want you to rewrite this in such a way we can use only the what we call the power rule. Okay, so how can I rewrite this? So we're going to rewrite. Okay, because using the quotient rule is actually honestly is a nightmare here, or the product. All right, how can I rewrite this? This is an x times x to the power a half plus. So I'm rewriting, I'm not computing derivative, I'm doing nothing. Fourth root is x to the fourth plus 5. Okay, I still rewriting, I'm not doing anything. No quotient, no power. Now, x times x to the half, we add the power, 1, so an times am, how many we have? N plus m. So I'm going to add the power, 1 plus a half would give me 3/2 plus. Here we have division, an over am, we take away the power. So here I will have x to the 1 minus a fourth plus 5. Okay, I'm rewriting it. So finally I get x to the 3/2 plus x to the minus 3/4 plus 5. This is my f of x. And believe me, it's way easier than sitting down and taking product and taking quotient. It's really a nightmare. We don't need it in this scenario. So finally, I need f prime, and there is nothing left for f prime in this case. That's the power rule. That's 3/2 x to the 3/2 minus 1 plus, minus 3/4 x to the minus 3/4 minus 1. So it's going to give me minus 7/4. Derivative of 5 is just a 0. Okay, and now Elizabeth is correcting me. Elizabeth is usually right. Thank you very much, Elizabeth. So it's 3/4 minus 1, my apology. So 3/4 minus 1, so it's giving me minus 1/4. Thanks, Elizabeth. All right, so this is minus 1 over 4. So finally, I will get 3/2 the square root of x minus 3 over 4 the fourth root of x. Okay. I had questions about this problem.
How did you get x to the 3 over 2 when you multiply like x to the first times
This
x
one?
Yeah.
This is here. X to the power 1 times x to the half. The law of exponent tells you what do you do with the powers? You add them.
Yeah.
So 1 plus a half will give me 3/2.
Okay.
All right?
Yeah. Before I did that, where I messed up was like I did the power rule first and then like multiplied.
Well, here you can't use the power rule here.
Yeah, that's where
You
I messed
can't.
up.
The only way you can, if you want to use here, you have two choices. Either product rule first. If you don't combine them, you have to use the product rule. Are you with me?
Yeah, yeah.
But I don't want to use the product rule. I told you not to because I don't think it's efficient. It's correct,
Right.
but not efficient. And there is a difference between correct and efficient. It is correct, but it's not efficient. If you combine them, it's become much more efficient.
Okay.
All right, and the same here. If you want to use quotient rule, it's correct, but it's not efficient.
Right.
It's way more efficient. All right.
All right. Thank you.
Sure. Okay. We proceed now. Number F, I guess. Actually, I want to do number C. I did it for some student yesterday, but I would like the whole class to be part of it. We have f of t equal, because I usually like those type of problems, I'm telling you that, minus 5x over 5x squared, plus t. This is t, okay? And I'm telling you that x is a constant. Okay, so the variable here is t, x is a constant. And the question is find f prime of t. Right? So x is a constant in this problem. The variable is t. Okay, so I have to be very careful. So with this in mind, let us find f prime. How would you find f prime in this problem? Quickly. You guys help me so I can do as many problems as possible. So how would you find f prime? Absolutely the quotient rule. Is this divided by that? Okay, so let us use the quotient rule. So equal to the derivative of the numerator times the denominator minus the numerator times the derivative here. And the whole thing divided by the denominator square. Okay, and sorry, this is 4xt minus 5x. So this is equal to. So remember what's your constant and remember what's your variable. So that's equal to. So this is the denominator. There is nothing to do with it. We just keep it. It's the numerator. What's the derivative of 4xt? Be very careful. X is my constant. The derivative of 4xt is absolutely 4x. You know, this is my variable. So 4x for me is a constant. If I tell you find derivative of 4t, you tell me it's 4. For 8t is 8. So derivative for xt is 4x. Minus, what's the derivative of 5x? Each one of you answer the question, at least in your head. 0. Why 0? Because my x is a constant. So that's going to give me 4x times 5x squared plus t minus 4xt minus 5x times. What's the derivative of 5x squared plus t? That's the sum rule because we're adding. Derivative of 5x squared, that's 0. Plus the derivative of t, it's 1. And the rest you combine. So we don't really have a lot. The rest is actually kind of, it's algebra, so I can distribute. I will have 20x cubed plus 4xt minus, be careful when you distribute the minus, a lot of you messed up here, minus plus 5x. And then those over the denominator square. So this would give me 20x cubed plus 5x over the denominator square. Okay, so don't let variable really kind of get to you. Okay, always what's constant, what is variable. In this problem, t is my variable and x is a constant.
I have a question.
Please go ahead.
How did you get 4x out of 4xt minus 5x?
Okay, let me ask you this question. What is x in my problem?
It's a constant.
Very good. So if I have 8t, now forget about 4x for a second. 8t plus 6, for example. What's the derivative?
Just 8.
8, right? Derivative of 8t is 8 plus 0. With me?
Yes.
If I put 9t plus 5, what's the derivative?
Just 9. But 9 plus 0.
Yeah. Now, if I put a is a constant, and I put 8t plus 6, what's the derivative?
Just a, right?
Right, a, because a is a constant. A would be 9. 8, this is just a constant. Okay? Now I have 4xt plus 5. What's the derivative? X is a constant.
Just 4x.
Yeah. It's just 4x. It's a constant. If you have 9, it's 9t, derivative is 9. 8t, derivative is 8. So what's playing the role of 8 and 9 and a is the 4x. That's what t is multiplied by. Got it?
Oh, okay. Yeah, that makes a lot more sense.
What?
That makes sense.
Yeah, it's just what t is multiplied by the constant for x. Okay, so don't let x really get in the way. Because I told you it's a constant, so it's going to be for x.
All right. Thank you.
All right, so where we are at now? So we are at f. We have the function f of x equal x squared times cosine cube x. Okay, I need to find the derivative of this function. All right, so what do you see when you see this? And when I tell you what do you see, I mean product, quotient, chain. What do you see first when you see this function?
Product.
Product, absolutely. You start seeing a product. That's x squared times x cube, cosine cube x. So to find the derivative, so that's a product. So we have to do the product rule. So let's do the product rule. So f prime of x equal, okay, the derivative of x squared times this plus x squared times the derivative of cosine cube x. Okay, that's the product. All right, now piece by piece. This is easy to x. This is cosine cube plus x squared times. Now, cosine cube, I just actually did it at the beginning because some of you had difficulties with. If you're finding the derivative of cosine cube, what do you do first? First, not second. Rewrite. Very good. We rewrite it as cosine x to the power 3, the derivative of that. Unless you write it this, you're going to be confused. Now we're going to use the chain rule here. For this one, this piece, we use the chain rule. Okay, and the chain rule here tells me that the inside is the cosine and the outside is u to the power 3. So the rest now is not hard anymore. So that's it, 2x plus x squared. The derivative of the outside, which is 3 u squared, but instead of u, I put the cosine x times the derivative of the inside. That's why it's a chain. So finally, I get 2x plus, there is a 3 in here, I can pull it out, x squared cosine square x times the derivative of cosine is minus sine, so I can put the minus in here and get me the minus. Okay. All right, now we move. So if anybody have any questions while I'm doing the work, please let us know. So we'll do number 8.
When you take the derivative of cosine x, is it negative sine x?
Yes.
Or
Yes.
oh, okay.
Derivative of sine is the positive. Derivative of cosine is the minus.
Okay.
Okay. Just those things you have to memorize, guys. I mean, I know that you guys, because the way we're learning online, you can look them up. But believe me, at the long run, it's going to hurt you if you go view them anymore. It's essential that you basically memorize them. And when I taught face-to-face, students had no access to anything, but something I can't do right now. So for your own good, memorize this stuff. So here we have f of t equal sine 2.
I have a question.
I'm listening.
So the final answer is 2x cosine to the power 3x minus because
Yes.
the sine x was negative at the end.
Yeah.
Okay.
Yeah. So instead of writing is a third line, so I could have kept plus here and put the minus here, right?
Yes.
But then I would actually, it will be, better to rewrite it this way. Plus minus minus 3x squared cosine cube sine. All right.
All right. Sounds good. Thank you.
Now, f of t is sine 2t plus cosine 3t. The whole thing to the power 3. And my question is find f prime at pi over 2. Okay. So as I said at the beginning, if I want f prime at any specific value, first I find f prime of t for any value of t, and then I substitute pi over 2 for t. So we don't start by substituting, it's wrong. First, we find it for any value of t. So what is f prime of t? Okay, what do you see here? Again, when I say what do you see, I meant to find the derivative, chain rule. That's absolutely the chain rule. This is my inside. Clearly, that's my u. My outside is u to the power 3. So the derivative would be u 3 times the derivative of the outside, which is 3 times u squared, that's the derivative of the outside, times the derivative of the inside. All right, so this is equal to 3 times this expression to the power 2 times. Now I have to deal with the derivative of this function. What's the derivative of sine of 2t? Sine of 2t. So I'm immediately thinking of chain rule. Okay, so derivative of sine is cosine. Is this correct? Is cosine 2t correct? Is the derivative of sine 2t cosine 2t? Yes or no?
No.
Because?
You gotta multiply by the inside and then the derivative of sine.
I have to multiply by the derivative of 2t. So I will write it as a chain rule. So it's cosine 2t times the derivative of 2t, which is 2, of course, plus cosine. Derivative of cosine is minus. So now I'm going to put minus immediately here. Sine 3t times the derivative of the inside. Okay. Now finally, I'll put things together. So this is equal to 3. I mean, there isn't that much to put together. Times derivative of that 2 cosine of 2t minus 3 sine of 3t. And this is sine 2t plus cosine 3t. Okay. Now I found the derivative for any t. Now I zoom in and I evaluate it at this particular value, pi over 2, which means I plug in pi over 2, right? Yeah. I have to plug in pi over 2 across the board for every time there is a t. And that's again a problem you faced in your quiz yesterday. So it means wherever there is t, I put pi over 2. So I will have here sine of 2 times pi over 2. 2 times pi over 2, it's a pi. Plus cosine of 3 times pi over 2 means 3 pi over 2 times 2 cosine t is pi over 2. 2 times t means 2 times pi over 2, that's a pi, minus 3 sine 3t 3 pi over 2. And now we compute. Those are easy values. Sine pi is 0 plus cosine 3 pi over 2. Remember your unit circle. 3 pi over 2 is right there. The cosine is the x coordinate. So the cosine is 0. So basically I am done because I have a 0 in here. But let us just to review the value of sine of cosine. Cosine pi is the x value here. That's the -1. Sine 3 pi over 2 is, that's right here. So sine 3 pi over 2 is -1 plus 3, which is going to give me a 0 anyway. Okay. All right, so number 9, 10, and then we proceed. Okay, number 9. We have the function f of x equal the square root of 1 plus 3x. And one of the typical questions you will encounter tomorrow, equation of the tangent line at the point 2 f of 2. Okay, so this is a typical question. First, we need to find the derivative. The slope of the derivative at 2 is the slope of the, the value of the derivative at 2 is the slope of the tangent line. So we need f prime. So first, I have to rewrite because I need the derivative. So this is going to become that. Okay. Then I need f prime because I need the slope f prime of x equal. Again, that's a typical chain rule problem. That's my inside to the power a half. So this would be a half times. So this is my u. That's really my u. That's my inside. And that's an easy inside here. So it's going to be a half times. Derivative of u to the half is a half times u, which is 1 plus 3x, to the power a half minus 1 times the derivative of the inside. It means the derivative of 1 plus 3x. So finally, I will get 1/2 1 plus 3x to the minus a half times the derivative of 1 plus 3x, it's 3. So this would give me 3/2, and actually 3 over 2, because I have a minus in here, the square root of 1 plus 3x. Okay, now I need the slope at 2. So prime at 2. So the slope of the tangent line the slope of the tangent is the value that the derivative take at 2. So it's equal to 3 over 2 times, I plug in 2 for x. I will have 1 plus 3 times 2, that's a 6. So it gives me 3 over 2 square root of 7. So that's the slope. Now I need the point. The point is 2 f of 2. Now what is f of 2? F of 2 is the value that the function takes. At 2, the function takes the value square root of 7. Then finally, the equation. Y minus, that's the slope, times x minus 2, y minus square root of 7. Okay? And you can simplify it a little bit, not much. X minus, you should distribute here. The 2 and the 2 simplify. You have 3 over root 7 plus the square root of 7. And the idea is that when you graph, so to make sure that your answer is correct, you can graph the function y equal square root of 1 plus 3x. You go to the point 2, you sketch this line. So if you sketch both of them, you should see a tangent. If you don't see that, it means your line, this equation is absolutely wrong. Okay, so if you want to check your work, you take the line, you graph it, you graph the function, and you should see that you have a tangent line right there. Right? Sorry. Let's look at the last questions you guys have. I'm listening. Okay. Number 9. Okay, what it is? We have the function f of x equal, I think I've done this before. Sorry, that's number 10. 2 sine x minus x. And the question is, find the values of x where the slope of the tangent line is horizontal. Okay, so the slope is horizontal. This occurs when the derivative is equal to 0. So we have to find the derivative, set equal to 0, and solve for x. So let's see f prime equal to 2 cosine x minus 1. All right, and then we're going to set this equal to 0. This would give me cosine x equal to a half. And now we go back and try to remember when is the cosine equal a half. So we go to our unit circle right there. And we want the cosine to be 1/2. The cosine is the x coordinate, a half. So this is one angle, and that's another one. Okay, and then we try to remember what are the values. The angle whose cosine is a half, the angle whose cosine is a half, that's the pi over 3, that's the cosine. And there is another one here, so which is 2 pi minus pi over 3, which is 5 pi over 3. Okay, so those are the one we pick. So we have x equal pi over 3 and x equal 5 pi over 3. Okay, but then you start adding the 2 pi's. So then you will have pi over 3 plus or minus 2 pi. You have to add both, pi over 3 plus or minus 4 pi, etc. And here you will have 5 pi over 3 plus or minus 2 pi, 5 pi over 3 plus or minus 4 pi, and so on and so forth. Okay, so you pick up from the unit circle the 2 basic angles, and then you add and subtract the 2 pi's, and you get everything else. Okay, all right. These are your questions. Of course, your exam tomorrow will have implicit differentiation. So I hope you guys are doing those problems. And at the end, I would like to do one more problem with you, unless you have any specific questions yourself. Okay. All right, so, okay, let's take this problem. And the question is, so as I said, make sure you can do all those. Make sure you can handle those. Sketch the graph of f prime for each of the function below. So I'm going to pick one of them, and I'm going to sketch the graph of the derivative below it. So suppose I pick this one. Okay, so down here, I'm going to sketch the derivative. Okay, so let's assume this is, even though it looks off, this is -1, and let's assume this is 1. Right, so what is really going to be the derivative? Up to -1. What's really going on? What's the derivative up to -1? Up to -1, the function, at least in this graph, it looks a line. So for here, up to here, let's see what's the slope of this line. So it's a line. So the derivative here, because that's a line, is going to be the slope of this line. So to sketch the derivative, I need to sketch basically to figure out the slope. So what's the slope of this line? So if I assume this is a 1 in here, so I take those 2 points. The 2 points would be -1 and 0. And I can take this point, which is -2 and I don't know how many here, -2 and 10. Okay. So my slope is going to be -10 here. All right. And here, the slope is 10. Right. Now here, it is curving. So the slope is not constant. The slope is going to change. So let's sketch the derivative. Up to -1 is a line, straight line. It's a line at minus 10, right there. Okay, because the function is linear. Now, between 0, minus 1, and 1, what's happening? Now watch carefully. At minus 1, the function is not differentiable. The derivative doesn't exist because from the left, the slope is negative 10. From the right, the slope is positive. So at minus 1, the derivative really doesn't exist. But now what's happening between minus 1 and 0? The derivative is positive because, and it's actually getting less and less positive. At 0, it is right here. The derivative is 0, and then it's getting less negative and more negative. So that's how we're going to do that. I'm going to start somewhere here, and then my derivative is positive, but it's heading towards 0. But at minus 1, it's not differentiable. Now between 0 and 1, so at 0, we have a horizontal tangent, crucial. It's reflected right there. Between 0 and 1, it's negative, and it's getting more and more negative. And at 1, we don't have. It's not differentiable because the slope from here and the slope are very different. So up to here, it's going to go down somewhere, open right there at 1, and then it's going to jump all the way to 10. Up to here to 10. So that's going to be the graph of my derivative. So at minus 1, we don't have, because we don't have a tangent line intuitively. The function has a corner. From the left, you compute the limit, you're going to get 10. From the right, you're going to get a positive number. So right here, the function is not differentiable. Right here, there is no derivative. So that's why we have those open circles. And then in between, it's in between. We can graph in between. Okay? Why are there no closed circles? Because the derivative doesn't exist. There is no derivative. Because for the derivative, you need the slope from the left and the slope from the right to get close to a fixed number. My graph looks like this. So if I compute the slope from the left, I'm going to actually get minus 10. If I start computing the slope from the right, I don't know exactly what I will get, but I'm definitely going to get a positive number. So right here, so f prime at minus 1 do not exist. And how do we reflect graphically that there is no output at minus 1? We reflect it by having open circles. Look, did I answer your question? This I hope. Look with me. Okay. Yeah. So that's how we graph this one. And the other one, usually, I think time is up. Try to do it, and I'm going to put the solution on Blackboard hopefully soon for the graphs, because I forgot to put the graphs. And make sure you can do those type of problems. All right. And would you guys like to start the exam early tomorrow?
Yes.
Yes. Okay, so we start tomorrow.
Yes.
Okay, all right. Help me if all of your answers. So let us start at 7:45 tomorrow. You're gonna make me wake up, 15 minutes earlier, which I don't like. Is it 7:45 fine for you?
Yeah, that's good.
Okay.
Yes.
All right. So tomorrow we start at 7:45. I will email everybody just to make sure the whole class is aware of that. And good luck for tomorrow. And make sure you study well. Okay, and you have to show your work, and that's crucial. No work, no credit. You have to show me your work. Don't put answers from internet that you don't know how to justify, because I know that. All right, good luck. Bye-bye, guys.